3.2b. We're going to continue on with our prime factoring. In fact, we're going to use our prime factoring to do what is called on page 176 reducing fractions. Because we can use this method of factoring numbers into prime factors to help us reduce fractions to the lowest terms. And a fraction, according to your definition box there on page 176, says a fraction is said to be in lowest terms if the numerator and the denominator have no factors in common other than 1. What that means is our numerator and denominator, if we were to write the 6 and the 8 in prime factors, they would have nothing in common except 1. Okay, so let's see if these do. 6. We could write 6 differently than 6. Let's break it down into its prime factors. 2 times 3. Both prime numbers, aren't they? You can't multiply anything to get 3, anything to get 2. So those are prime numbers. 8. Its prime numbers are 4 and 2. Except for 4 is not a prime number yet, so let's reduce this 4 down to the next step to 2 times 2. So now we have 2 times 2 times 2. And what the book is saying is that this fraction is said to be in lowest terms if the numerator and denominator do not have any factors in common. Well, let's look. We have a 3 here, we don't have a 3 here, so there's not a 3 in common, so we're good there. But we have a 2 here and we have 3 2's here, so we have a 2 in common with the top, with the bottom. Even though there's more 2's here, by having 1 up here and at least 1 down here, we've got those 2 in common. Well, if you remember, 2 over 2, or any number over itself, is 1. That's the case. We don't really need to show this 1, so we're just going to get rid of that. We're going to divide 2 by 2 and get 1 and throw it out. And that gives us 3 over 2 times 2 is 4. Alright, so now let's look and see if this one has any common factors. Well, 3 is a prime number, so it doesn't. And we have 2 times 2. There's nothing in common with those 2 at all, so 3 over 4 is in lowest terms. It's the same as 6 over 8, but we've reduced it to its lowest term, so it can't be reduced anymore. So we're going to do some practicing on that, because it's important to be able to reduce the lowest terms. So let's take 12 over 15. Now when you get to some bigger numbers, some numbers that are into the hundreds, it's a little bit trickier to come up with what is that number in lowest terms. So when we use the factor tree, it makes it a lot easier. So what we're going to do is we're going to look at 12 and we're going to break it down into its prime factors. And rather than doing the whole factor tree, I'm just going to write them for you. 2 times 2 times 3. So 2 times 2 is 4 times 3 is 12. All 3 of these are prime numbers, so we're good. And let's do the same thing with 15. 15 is easy because it's just 3 times 5. That's your only other option. Both numbers are prime numbers. One thing that's important for you to know is every single prime number is odd. Not all odd numbers are prime, but there's none that are even. So if you've got 3 and 5, you already know these are odd, so it could be the likelihood of them being prime is good, because you can only have odd numbers that are prime. There are some odd numbers that are not prime. 15 is an odd number, but it's not prime. Whereas 17 is an odd number, and it is. So just because you see an odd number, don't assume it's prime, but chances are high that it will be. Okay, so anyway, in this case, 12 can be written as 2 times 2 times 3, 15 can be written as 3 times 5. We look and see what we have in common with the top and bottom, the numerator and the denominator. We have 3's. We are not canceling the 3's. We are dividing 3 divided by 3, which is 1. And 1, any number times 1, if you remember from last chapter, is going to give it itself, so it doesn't even have to be there. So that's what we're doing. And the reason I'm putting those marks on there is just to show that we did divide. So now we just multiply what's left. Okay, 4/5. If we did this right, this will be in the lowest terms, and you're done. You don't even have to think, well, wait a minute, can it be reduced any lower than that? No, it can't. Alright, so let's try a couple more here. let's do 20 over 24. Alright, so I'm sorry I'm rushing here. Don't mean to do that, but I'm just going to do 20 and write it as its prime factors, just like that factor tree that we did earlier, because I know that 4 times 5 is 20, and 5 is prime, and 4 can be broken down into 2 times 2. That's why I was able to write that so fast. Then I've got 2 times 2 times 2, which is 8, and I know that 8 times 3 is 24, and I know 3 is a prime number, so I can just tag that on there. So if I were to do the factor tree, in fact, let's just do it for 24. I've got 2 and 12, break that, circle. 2 and 6, circle that, and 3 and 2, and I know both of those are prime. So I have 3 2's, and I have a 3. So that's where that came from. And as you get going on these, you can start doing a lot of this in your head. Alright, now I'm going to look and see what I have in common. Well, I have 2 2's, and I have 2 2's. So I get rid of all the common ones to the top and bottom, and my answer is this fraction reduced. So 20 over 24 is the same as 5 over 6. Alright, so let's do 1 or 2 more since we do have some time here. Let's look at 6 over 42. Well, 6 can be reduced to 3 times 2. And 42 can reduce to 6 times 7. If you remember your multiplication tables, that really helps. 6 times 7 is 42. 7 is prime. 6 isn't, but 6 can be broken down into, just like here, 3 times 2. Which means I can cancel those, cancel those. Okay, this is very important to realize. We just canceled everything from the top. That does not mean that we're left with 0. Because one of the things that's important when you're factoring these down is everything in the top and everything in the bottom is also multiplied by 1. Okay, because 1 is a prime number, right? So 1 can be part of this whole thing. So we've got 1 times, in fact I say 1 is a prime number. 1 actually is not a prime number. According to the definition, it's any whole number greater than 1. But 1 is part of the factoring here, because we can take 1 times 3 times 2 and get our 6. If anything else, the only reason I say that, I put the 1 there, is because you got to have a number up here. It can't be nothing. And nothing is not the same as 0. So we don't have a 0 up here. We have a 1. Okay? So whenever you cancel everything out, make sure you put the 1 up there, because it is right there. Okay, so brings us to one more here, and then we'll call it good for this lesson. Let's do 36xy over 120x. Alright, that being the case, we're just looking at the numbers right now. Let's not worry about the variables, the letters. Let's just worry about the numbers. And the numbers for 36 is 2 times 2 times 3 times 3. 2 times 2 is 4, times 3 is 12, times 3 is 36. And let's do our 120. 2 times 2 times 2 times 3 times 5. Alright, well let's cancel. Or not cancel, let's divide here. So we're going to divide those, we're going to divide those, and we're left with a 3, and we're left with a 10. Okay, what do we do with our x's and the y's? Well, the same thing. I have an x up here and a y down here, just like I had a 2 here and a 2 here. So I can divide these out, and they disappear. I have a y left on top, so I'm just going to leave that y since there's nothing to cross it out with or divide with, and I'm done. 3y over 10. Alright, so we're going to get started on problem set 3.2 in a minute, so turn the tape off and get ready to start on that one.